This video is going to talk about topic 4.5 or stoichiometry. So the statement, the objective for this topic is to explain changes in the amounts of reactants in products based on the balanced reaction equation for a chemical process. So we're not actually going to go through an example problem with this. I'm going to give you some guidelines, kind of a roadmap of how to think about this, because stoichiometry problems can widely vary. And you're going to see different components embedded into different problems. So this is going to become something that these relationships, these connections almost need to be routine. So we're going to go through kind of a roadmap to map out how we might think about a different reaction and what information we're given versus what we're being asked for. Okay, so here's my roadmap. When we're looking at it, the left side is dealing with compound A, the right side is dealing with compound B. Okay, so we're always going to go from A to B. So you use stoichiometry anytime you have a question that gives you information about one compound in a reaction, but then asks you about a different one. So if you're given information about silver nitrate and you're asked about silver chloride, you know you're going to be doing some stoichiometry somewhere in there. Because if you're given information about one compound, but asked about another, you're going to have to do some sort of these pieces. What you have to do depends on what you're given and what you're being asked for. So the first one we're going to look through is kind of our standard gram to gram or mass stoichiometry. No matter which version we have to use, we're always going to use the mole ratio. So we're always going to use our coefficients, that ratio between A and B. That's our crossover. That's how we get from A to B, is that mole ratio of the coefficients. Okay, so we're always going to be multiplying by the ratio of B over A. We're always going to do B over A because we're trying to get to B. We're given A. Whatever you're trying to get to goes on the top. Whatever you're given goes on the bottom. So we're always trying to get from A to B, therefore it's going to be the ratio of B over A. Now, side comment, just because it looks kind of like what a chemical reaction equation might look like, the movement from left to right, it isn't necessarily always a reactant to a product. It could be between two reactants. It could be between two products. It could be you're given information about a product, asked about a reactant. You could be given information about a reactant, asked about a product. So it doesn't matter whether it's product reactant. That's why I used A and B, because it's just two different compounds is what you're looking at. No matter what, you can always use that mole ratio. So if we're given grams, in order to get from grams to moles, you have to think about that step of the process, that step of the conversion, because no matter what, you need to get to moles, because that's how you get from A to B. So how do I get from grams to moles? I'm going to use the molar mass. So these are our normal gram to mole conversions. So you're going to use the molar mass of A. That'll get you into moles of A. You can use the mole ratio. Now, if I'm asked about mass of B, I'm going to use the molar mass again. Okay, so then I get from moles to grams. So if we think about these in different pieces, no matter what, you always need to get to moles because that's how you get from A to B. My first question is, well, how do I get from grams to moles? Use molar mass, okay? Once I use my mole ratio, how do I get from moles to grams? I use molar mass again. Okay, second scenario, we're gonna go straight across the middle. If you're given P, V, or T, it says and, if you're given some two, oh, it says and because you need all of those variables, duh, your unknown is the N. Okay, so if you're given pressure, volume, and temperature, your unknown is your N. As soon as you see P, V, and T, you should be thinking PV equals nRT. That's how you're gonna get to N. Because you know P, V, R is a constant, T, you can solve for N, that gets you to your moles. The question is always, how do I get from what I'm given to moles? Okay, so now I use my molar ratio, I go from moles of A to moles of B. Say the question asks for P, V, or T. So any of those, so if one of those has changed, you can use the initial condition or whatever new condition they're giving to you, and you can take your moles and solve for whatever they're asking for. Okay, so last part is if you're given concentration and volume, you're gonna use molarity to get to moles. So molarity is moles divided by volume. So if you're given your concentration and your volume, you can use your molarity or your yeah, you can use that molarity equation to get to your moles of A. So again, the question is always, based on what I'm given, how do I get to moles? Use my molar ratio, now I'm in moles of B. Depending on what you're asked for, you can use molarity again if you're asked about concentration or volume of B. It all depends on the information. Now, you don't have to go necessarily from grams to grams. You could go from grams to PV or T. You could go from grams to concentration. That's why it always goes through the mole ratio. So the questions you should be asking yourself is, based on the information I'm given in A, how do I get to moles? Okay, what am I going to use to get from my starting information to moles of A? Okay, once I'm in moles, I can use my mole ratio. That's easy. That's the same for all of them. So I'm going to use my coefficients. Now I'm in moles of B. The next question I'm asking myself is, how do I get from moles to whatever I'm looking for, whatever the question's asking for? So it's really important to read and dissect your question to see what are you given and what are you asked about. That's going to guide what steps you have to do, because your pathway can follow any of these paths. No matter what, it's always going to go through the mole ratio, which means your first question is always, how do I get from my given to moles? And then your second question is, how do I get from moles to whatever I'm asked for? So that's our general roadmap for stoichiometry. This gets better through lots and lots of